Okay, welcome to this awesome conference. We continue with this talk in Conf42. Thanks for inviting me, and also it's a big pleasure to be here. So today we talk about the adding security to development for reliable continuous delivery, and also this is me. We start for this. Who is Jhonnatan Gil Chaves? This is a simple human that I love Linux and also love share knowledge around for the tech ecosystem. I try to make more easily our lives when we try to develop and start deploy it on cloud or on local on our internal providers that we have on our countries. So that it's my passion. I sincerely love using that. That is my social network at Jhonnatan24 in GitHub, in YouTube, and also in X or Twitter. If you can contact me and add me on LinkedIn, I use Johnny Punk. You can find me. And I want to share with you this phrase that is from Confucius. Life is really simple, but we insist on making it complicated. That's as part of our lives. So continue here. This is our agenda for today. We talk about for containerized applications, what is exactly this, how we can use that, and address this using the software development lifecycle, general challenges using these containerized apps. What is the principal challenge here? Address the challenge using the software development lifecycle, a little demo, and a couple of conclusions here. So we start at this part. At this part, we talk about for containerized application, but what exactly is a container? The container is exactly how we can encapsulate our process, encapsulate our source code using the Docker file. I think is the more simple way for using that. How to using this Docker file for split our commands and exactly route for our applications. How we can add in and use our proper ecosystem, our proper operation systems. So at this part, we define exactly every step that we need to cover for our packaging this compilation of source code. That is the one part. And also we have the part of the containerization, right? And this part of containerization is the how do we move from our package and how do we can support our and start using this Docker for using that. The second part is, hey, what kind of initiatives are around here? We found exactly Open Container Initiative, that is OCI. And also this container initiative talk from a couple of values. These values are decomposable, portable, decentralized, open, minimalist, but we're compatible. But one biggest part here is that around for secure, how to isolate should be pluggable and add the cryptographic for these containerized application and generate more stronger container for our application. How to add in the part of the auditing for this container and generate this layer for security side. That it's pretty awesome. And also we have a couple of benefits using containers. The first one is about for portability, how to use this portability for more very quick this package for software and move from one side to another side, from what cloud environment to our bare metal or our centralized definition for our infrastructure. The second one is the agility that we generate for all teams around for that. Now, how do we generate this easily way to deploy the application? And another is the isolation, because we generate this isolate para software and generate their network around for this containerized application. And also we talk about the resource efficiency, because when we generate these containers, we reduce exactly the consume about the memory or CPU and disk about for this piece of software, and how do we can drop this in all around for our orchestration side. So that is a couple of images that I generated using the Hugging Face and also the DALL-E generation for images, and how do the IAA generate these images for us, and how do the IAA seems the containerized world. So when we talk about the software development lifecycle, we talk about these could be focuses about these benefits or feature that we enable when we talk about this. So from one side we talk about the accelerated development and deployment side. That it's very awesome, because when we start this containerized move internally for our companies, we enable these capabilities for all teams, not just for development. We enable that for the testing team and the operation teams, and also for the DevOps, DevSecOps, and SRE or platform engineering around for this ecosystem that we have internally. The second one are related for portability and reproducibility. That it's awesome, because when you generate these Docker files or these container applications, you move from one side your container application, and also you can move this application for another part and deploy very quick. That it's pretty awesome. Enhance scalability and resource efficiency. That is talking previously about the CPU, memory, and disk drive around for that. Simplify microservice architecture. When you start that using the Dockerized apps for your teams, you enable exactly these capabilities for move very quick, and also you support the architecture that the principal architecture definition was made for your teams, and also the architectural department behind of, and how you can drop this using the containerized world, and you support very quick these new capabilities for all ecosystems, for the architectural designs, or generate this valuable for all teams around for the containerized world. Reduce the deployment friction, because you generate this and generate more repeatable software, and generate streamlined testing and quality assurance, because you drop these pieces of software and you can test very quick these pieces of this piece of software, and generate very easily these movements internally for this generation. So enhancement, security, and compliance, that is the focus that we talk in the next slides. Improve collaboration and communication, because you reduce this communication side, and also you involve all capabilities for DevOps side. And when you added this DevOps culture inside of, and we added the security part, we enable this cadence for all teams, and how to this cadence works for all, and how do we can generate and reduce this friction from one side and another side, and how do we can talk more efficiently and generate more software, quality software for our ecosystems, and deploy more easily way, and also reduce this friction from all teams around for, and also reduce cost, because when you reduce exactly your scope and you generate this blast radius in a minimal way, you generate this reduction for all around for that. That is could be when you start for that using the best practice, the software development lifecycle, but you need to talk about that inside of your company, because when you define this, and also you need to move internally for the companies, it's not easily to sell something like that, because when the companies start to generate this DevSecOps or DevOps move and DevOps culture, that it's not easily to sell them, because they now open this mind, and this mindset is very difficult to sell at the beginning. So we support here all these capabilities for the software development lifecycle, using these phases for development, for deployment, and also for the operation. Because when we define this from one part, that is for the develop side, we enable these capabilities for the development team. But what happened with the development team also using the Dockerized application? They have the capabilities for deploy and explore and expose internally for their computers this source code. But what happened when we move this for, hey, we need to deploy that for development environment, or for QA environment, or for testing environment, for lower environments, and also for production? That it's the next challenge here. And also, when I deploy the application, I need to start the operation. When we start the operation for this application, we need to generate these capabilities for all ecosystems, right? Because the IT guys need to take these features, how to they can access to these capabilities, and how to we can enable these capabilities for the Dockerized apps, how to we can enable that using software around that, right? So what is the challenge here? The general challenge here are related for image vulnerabilities, the misconfigurations, supply chains attack, and also the identification and access management. You see here in the image the OWASP top 10 that is related for Docker. And when you start Docker, you start talking about the security side, how to you can drop this security for the all blast radius that have the Dockerized images that you have for the containerized application. You need to identify exactly what is the your security posture, how to use in this security posture for generate the roadmaps and generate the plans for doing that, right? You need to take a look more in deep this, but we talk in this talk about for image vulnerabilities, misconfigurations, supply chains attack, and identify and access management. So for image vulnerabilities, we talk for one side that is related in a principal and the first part for start for this DevSecOps work. That is related for how to we can generate and reduce this blast radius using the image vulnerabilities, because this impact of the image vulnerabilities impact exactly for how to they can access to our operation system or the runtime side, or how to they can gain access to containerized application, and also how to they can get data from these containerized apps. Also, you need to reduce these attacks using exactly the image vulnerabilities. But how do you can reduce that? We talk more in the next slide about that. But the image vulnerabilities are talking about the weakness or flaws that containerized image had at the moment when you deploy the application, right? So you can generate this, and also you can reduce these vulnerabilities using scans behind off. So we talk in one tool that we generate in the demo side, and also that is one side. The another part is the software components that you have around for this image that you build it for the application, because internally for your application you had one part for the operation system, the second one part that is related for the runtime around for your application, and the third one is about for the application by default. So you have three action items here for protect. How do you can protect these items when you prepare and generate this image for your site, right? So we need to talk and identified exactly this vector than the definition from Docker side or the containerized side. The second one is related for misconfiguration. These misconfigurations are related for how to the applications generate, or could be the development team generate, or could be forget, remove from secrets or something like that for the containerizer world. When you use these misconfigurations and you identify that you need to take a look for these misconfigurations, you need to validate exactly what kind of misconfiguration you need to cover, because you need to exactly explore tools behind of. But these misconfigurations are related for, hey, how do we can access to these misconfigurations? Could be generate a misconfiguration by default from one Ubuntu image or Debian image or something like that, and also expose more than one port that I need. Could be, for example, you expose the port 22 that is related for SSH, and also, I don't know, could be exposed in a public site the SSH key for access to this Docker or containerized app, and that is the part of the misconfiguration that could be you need to cover here. And also how do you can exactly identify this exposure network, how do you can identify the file insecure definitions internally for this containerized app, how do you can address this using a couple of software behind of that validate from the community. For another part, you define the unsecure containerized registry, how to you can drop and identify what happened with this registry, and also if you could be exposed the configuration, the users and password for access to the, and how do they can gain access to this repository, and could be change the image and tag from your site and generate this in a evil image that is related for the image vulnerabilities, and generate that in that site. This impact generate a very big impact when the application will be deployed. You say because the application, or could be your system exposed unauthorized way for these misconfigurations, could be for one side for the database, or could be for the your registry, or could be for the data access. When you identify that, you take a look about, hey, I have this compromised world and I need to take a look in deep about this position and how to we can reduce this part of the misconfiguration side. The another one is really for supply chains attack. For supply chains attack, also we need to define exactly how to these attacks will be targeted for the software development lifecycle, how to they could compromise the containerized application. In this context, the attacker could be take and modify our code and generate this on the fly, and generate this process internally for the Dockerized app, and also the final product that you deliver for your customer generate an evil package of software, and could be take this data from your customers, generate and obtain and get this data from your customer. That it's very weird, because your customer could be, hey, I get my data out of your application and just share with you what happened here. Then could be they added to you could be a SLA part for the security sites, so you need to cover that from the 0 day for the start when you deploy this application for your customer, right? So the object here when we talk about the this supply chains attack, also we need to validate exactly what happened when this compromised application will be for our apps. What kind of security definitions we define it internally for our companies, how do these companies define exactly what happened with this definition for that. When the another part for the supply chains attack that is related for containerizing, and also when they access to this application, also for our source code, they can execute malicious code for the customer side. That is the biggest challenge here. How do we can reduce this blast, and how do we can reduce and generate could be a culture internally for our teams for reduce exactly what happened here. Another part that is the impact for these supply chains, the supply chains attacks that is related for data breaches, the application disruption, the escalation privileges, and damage our reputation because when you expose or could be take data from your companies or for our companies, that it's very difficult to try to generate and regenerate our reputation for our customer, right? On the other side, on the other hand, we have the identity and access management that is related how do they containerize it, access to another components internally and externally, and how do we can reduce this blast, how do we can exactly define for the container image and definitions for these access for another components around for our software. For one part, we define for the resource access control list, how do they can access to and generate this granular access to another mechanism and permissions associate for another resources. The attribute-based access control provides more flexible approach to access control evaluation for attributes, user, and containers. And also, if we deploy using this for Kubernetes, for example, we can enable the airbag, that is the role-based access control, how do we can reduce this access for the another side of components around for Kubernetes. And another part, the challenges here are related for the scalability, complexity, and visibility, because when we drop here this part of the piece of software containerized, we define exactly the this little piece of software, and this piece of software will be grow and reduce these capabilities when the software grows for explore more for the customers, right? So we need to address the challenge for the next topics. That's another images related for the AI, related for to these challenges that we need to talk in the software development lifecycle. So for one side, we need to identify very quick the vulnerabilities and also the misconfiguration and supply chains and IAM enforcement. How do we can address using tools internally, because when we talk about in DevSecOps, based on DevOps, we talk from one focus that is related for pipelines. When you define these pipelines for the company, you enable exactly the capabilities for your software to deploy more easily, but not exactly you deploy very quick without quality or unsecure software. The definition internally for DevSecOps, when you generate these pipelines, you enable another capabilities for the software pieces that you deploy every day or for every hour or every minute, and added these security capabilities too for the software that you deploy, right? So for this challenge, we can explore these tools around for the CNCF too. that is related exactly for the security side, that is taken from the CNCF that we talked at the beginning of this talk, that is related for the software, the Cloud Native Computing Foundation, and this is the focus for currently tools that are built from the community for the community, and also ones are part for the one vendor or another vendor, or could be from one cloud provider or something like that. But you have these tools and you can explore, depends for your needs and exactly how to you add these tools for your pipelines or software development lifecycle, depending on the phases that you are currently have for deploy the software. So we can move very quick for the demo. This demo are related for how do we can explore a couple of this software inside here. Let us move here for the demo side. Let me move for that. And also I drop here this, and also I close this, and we can open the readme, right? And also that's it, and drop here. So we have this repository, Conf42 2023 DevSecOps, and we have here exactly the step-by-step for generate one image here, and also you can use this using, I don't know, could be Docker or Portman or another container application that currently you have in your company, and start with that, right? So we suppose that you have here in a pipeline, and you clone exactly the pet link here, and you download here. I currently download this source and just join to this folder and move internally. And also I need to create this Docker image using the Docker file, create a Docker image, and also we can enable this and execute this part for the applications, but we don't need exactly run that. And we exactly, if we check this the deploy clinic, we have two Docker files. One Docker file that is related for compile the application using Maven, using internally configuration for Java, that is a POM XML, and we define exactly here the move and or copy all the source code related here, and when the runtime start, compile this code and start the execution, right? But we have exactly the another Docker file multi. When you use Docker files, you can define the multi-stages here, and you can reduce exactly the blast radius using this multi-stages part. And also we have the first part, very similar for the previously, but we have here for another phases. We have here the production side, and from build, that is this part, we package exactly this base from source code and generate the GIR packages from Spring Pet Clinic, and also we reduce the blast radius because in this part just generate the GR definition and not exactly the whole source code that we have here. So we generate the couple of images here, and so we generate the first part that is related for Pet Clinic, and we generate here the Pet Clinic mini using exactly the Docker mini multi file or generate that. And also if we validate here Docker images and filter for Pet Clinic, we have here this couple of images, the Pet Clinic at mini and Pet Clinic app. And also if we check the weight for everyone, for each one, we saw here exactly the image weight from one side to another, right? And we identified exactly the app clinic mini is the less image here. For one side, if you validate or try to validate your Docker deployments, you can start for this validation side. That is the first scan that you need to execute for your operation in infrastructure, because this is part for your currently definition on the Docker side. So at this part, we define the counter trust, that is our currently installation for Docker, and also we mount from our etc for the operation system. In my case, for my Arch Linux inside of the container, and they mount in the read only, and also we mount the container, the application in read only, also the runc2, the system d2, and here the bartlib and the sock for Docker, that they need this execution for these container needs, that is related for Docker bench security, and also this generate these awesome results for your Docker configuration, and you can check this one about what happened internally for your configuration and provision in your infrastructure side, and validate exactly what happened if your Docker was misconfigured, right? That is the one's part for the misconfiguration for your Docker. And also, if you generate this unconfigured installation for your Docker, you can move in my site. I propose this for TLS because I open in my port, because I use for another POCs, but I don't enable the TLS communication, just open the plain communication for my Docker site. So you can check this and also validate exactly what happened with this one. And if you want or you need to check exactly for your move, and depends for your posture, and also depends for your time, for your team time, about for generate this and reduce these lags, about for security posture. That is the one side. The second part here, that is related for misconfiguration detection, and also we generate for the pet clinic, the application. If you remember, we generate two images. One images that is related for the pet clinic, that contains the whole source code, and we validate here this part for the validate this image, and also we validate another image that is related for the pet clinic mini, right? When we saw these files that is part for here, and compare these files, compare selected, we saw here a couple of differences from one side and another, but in general there are the same image when we build the images, and also we have the same results here, right? Because the pet clinic and the pet clinic mini are defined using an Ubuntu base, and also this Ubuntu base are vulnerable for this CVA. And if you want to validate what is the CVA, you have here the link for validate that. And if you check here, we can show exactly what is the severity for this. At this case is low. And also if you drop here, we can find for another in medium, but not in high level, right? So that is the one part. How do you can generate these misconfigurations for your application, right? Another part is related for the vulnerability detection, because you have for the misconfiguration detection side, but for the vulnerability, this generate one report, and also you can move for your application and drop here for your security team, and will be generate a couple of alerts here. But when you use a sneak, that is very similar. We can create here the one folder and move internally for this folder. We download the sneak for Linux and added the permissions for executable site, and also I just generate this path and add in this folder for the current site for execute, and we execute exactly in this part the latest images that we generated internally for generate this report internally for the sneak account, right? When we send and execute this command here, this as previous for this sneak authentication and generate and communicate your terminal with the sneak account. And also if we move very quick here for the website sneak, we saw here login here, and also we saw here our dashboard, and we have internally here the two projects, the pet clinic app and the pet clinic mini, and we saw here exactly the target for iOS. When we change for this, that is the same OS here, and if we drop the move for these results, we have 40 issues from one side, here 40 issues too, and also we have 20 million, another in low at the same, because the image that we scan at this moment is the same. We just reduce exactly the weight, but the image when we define for the Docker site, let me move here, we defined for our Docker site for this file and another is the same basic, that is Eclipse Temorin. This Eclipse Temorin we found that is based on Ubuntu site, right? So we continue here. We can also execute declare definitions, and sincerely I test this. For my site was very unstable because I need to generate more space on my disk so I can continue for this POC. But when we start for the supply chains and the AM enforcement, we generate here a lot of comments around for that, because these tools generate these reports, and when you generate these reports, you can also enable the capabilities for your team or something like that. So you need to start to how do you can verify the image and the provenance for this image. At this case, we generate using the Docker file, scan containers and images. Yeah, we can check a strong CI CD pipeline, and also we can access here and include access control, code reviews, and vulnerability scanning. And we check educate your development teams. That is the biggest task here, because don't depend exactly the tools, start to depend exactly the teams, and it's very difficult for our side. And another part is for adding this monitoring activity. And another part that I love sincerely is how do you can monitoring and generate observability for the different components around for the teams, and you can add it here. This as part depends of your how do you can deploy the application, and how do you can use this application, and how do you can explore your application and generate this observability stack for this application. And when we move for the AIM enforcement, we define here the less privileged principle. And if you saw here the reference more in the talk, I dropped a couple of links around for Docker site and also the OWASP, and they mention how you can generate this and using the less privilege and generate groups internally for your operation system, and what's the kind of user execute the application, centralize the IAM. So how you can generate this access for their another components around for the application, continuous authorization, audit and monitoring, Then again, monitoring and monitor your application, that it's one part for identify exactly in a predictively way for when you start for DevSecOps side, and automate this IAM task for validate exactly what kind of access the application had to another components around for this. So we can return here and also return for the application for the slides and continue here. So our conclusions: continuous deployment, reliable. We had this reliable when we enable this security tools, and also if we drop here these tools and also add it to the software development lifecycle and adding that for the pipelines are pretty awesome, because you generate and reduce um, the scope for these security vulnerabilities on your teams, and also you can stop this misconfiguration, stop this enforcement, and stop and reduce this blast for all principal challenge that we have internally for the software development life cycle and when you deploy the application. Generate the commitment for our teams. That is, again, return for the teams and how do they access the security side and access to the security training internally and start the security culture in our teams. It's very difficult, I think, this to latest conclusion, because when you involve the teams are very difficult, because not all dev teams are open to start for this journey when you start for security side, right? Then you start first for the tools, but you need to involve exactly the teams for made more easily your work. Yep, because at the end of the day, is the company valuable? Then you need to make more valuable using these components around that. So, a brief resume for today. We talk about for containers, the software development lifecycle, what kind of containerized application are not, the software development lifecycle, the general challenges here, address the challenge using the software development lifecycle, the Kubernetes Computer Foundation, about the glossary, about the tools, and how to these open source tools are enabled for us, and validate what kind of components we can check for the community, and also you can join for that. This is a little survey. Please, if you can help me, I appreciate a lot. Just could be take 1 minute for fill that. Also for today, thank you for joining for this session. I very happy to be here. So I appreciate this time with you, and also the seeing the Conf42 team. Thanks for invite me, and also for doing this today better. So let me return here and share with you this reference exactly that I talked for the OWASP that is related for this. Let me move here. No, not the pen. That is the top 10, and you can access to this. And this you can check exactly what kind of components you can drive for your containerized applications. And that's it for today. Thank you very much for access to this talk. Thank you.